Exactly. That implies that we were friends before.
Yeah. You always say we were.
I know. Okay, so he asked, what are we doing today? We're doing something new. The answer to that is, well, not really. The answer is really, it's a combination of two different things. Now, over there on the board, we're going to solve Millikan problems where the charge is moving, because yesterday we talked about, was it yesterday or Friday? Friday. We talked about when the charge was suspended. So I want to point out that this is no different than, I've got a couple diagrams there, and I'm going to draw them over here for the benefit of people that might be watching at home. When it's suspended, the electric force is equal to the weight force, right? When it's moving, then that means that the electric force is greater. And this one would be moving up, right? And if the gravitational force is greater than the electrical force, then it's going to be moving down. You draw it if you want, man. What you got to do is learn it. It's what works for you to learn it. You can tell. It doesn't take a rocket scientist to turn it out. It takes a electrical field scientist to do it. Doesn't even do that, right? You all know.
Why does everyone use rocket science as an example?
Apparently rocket science is hard.
Well, why don't we switch that up?
How hard to
Seems pretty hard to me. Now, I want to point out that you have done questions like this before. When we had an applied force to the right that was greater than the friction force to the left, which way did it move? There was a net force to the right. This is no different. The only difference is it's up and down instead of left and right. This is no different. We are taking an old concept and applying some new knowledge to that. Okay, I want you to realize that. And then once we solve for the net force, and I've got it on the board over there as well, once you've solved for the net force, then you can solve for the acceleration, and then for velocity, and then for displacement, right? Sure. Right, Heather, you with us? So, let's begin by looking at a relatively simple problem. And when I say relatively simple, I just mean we're not going to go too far in the questioning. Okay, we'll just sort of start small and work our way up, kind of thing. All right? So, by now you should have completed all your conversations that may be happening in cyberspace, and let's begin. The one thing that really makes these challenging is the scientific notation, right? And hopefully you're becoming more and more comfortable with that. I don't know if this helps. I'm going to write it down for you. If you choose to do this, you go right ahead. The mass is 1.0 times 10 to the minus 4. The charge Q is equal to 3.2 times 10 to the minus 19. You may have alarm bells going on in your head. You're realizing that that's actually equal to 2 elementary charges, right? No, that's coulombs. It's Q is measured in coulombs, right? That's okay. The plates are 1.5 centimeters apart. D. Do you have a funny feeling about centimeters?
Yeah.
Yes, your spider senses should be tingling. You should realize that that's 0.015 meters. It's got to be automatic by now how to convert centimeters to meters, you guys.
Wait, what was it again? One more time?
Divide by 100, it's 1.5 centimeters. We're going to move it to the left to 0.015 meters. Divide by 100, Nate. E is 1.0 times 10 to the 15. And again, you don't have to write this down. I insist on my grade 9s because I'm training them. I'm thinking that you guys are relatively well trained at this point. Okay, we are asked to find the, we are asked to find the net force. Now, the net force is 0 when it's balanced. So they're asking for the net force. Could I ask you for the net force? Could the answer be 0? I guess it could be.
If it's
Unlikely, right? It's unlikely that I'm going to phrase it that way. Yeah, it's unlikely. Okay, so I recommend drawing a picture just to help your thinking. Just takes a second. The net force is going to be the sum of those two forces. So we should do what? Solve for those two forces. Fe is equal to Q times E, and Fw is equal to mg. Right?
right.
Have I lost anybody yet?
No.
All I've really done is sort of set the table,
Why'd
right?
you do that?
Set the table. Set the
Why to do this?
Yeah. Throw that whole like thing, yeah.
Well, I'm just identifying what we know.
No, on the right.
Here,
Yeah, why'd you do that?
the electric force is up.
How do you know that?
It's always up. Actually, I shouldn't say that. It's almost always up, because if it was down, then gravity would pull it down, and then this thing would actually do what? Accelerate down faster than minus 9.8, right? Is that possible? Like, could we do that? Could I give you a problem like that? Sure, why not? Improbable, but not impossible.
What is that? 9.
This is Q times E. This is what we did on Friday, Lucas, when you were away.
That explains why I don't know what you're doing.
Yes. You should watch the video from Friday. Okay. So let's solve for Fe. So my charge Q, 3.2 times 10 to the minus 19, and I multiply by the electric field strength of 1.0 times 10 to the 15. And yes, I do apologize for the stinky scientific notation, but it's one of the things you got to get used to.
What does FE stand for?
Fe stands for the electric force, the force that is produced by the electric field.
Why is it Q?
Q is charge.
On it.
I get 3.2 times 10 to the minus 4 newtons. Did you get that? If you didn't, that's fine, but you should be able to get it with your calculator. Okay. To get the weight force, I'm going to need mass times gravity. Do I have mass and gravity? I did. I wasn't ogre-like. Wasn't stinky. I gave you the mass. I didn't make you figure it out, right? Because that's not really the point here today. So 1.0 times 10 to the minus 4, and the gravity is 9.8. Oh, now, there's always some kid that says, shouldn't it be negative 9.8, Mr. Bennett? Go ahead. You're right, it should be, Gage. Why does it matter here?
You want to find a difference between the two?
Yeah, because one is up and one is down, you have to have some way of mathematically showing that they're opposite directions, because indeed they are, right? Is that important here? Yes. Well, because it's down, right? It's down.
The down's not big enough.
But it's
It doesn't have to be bigger.
still divided by 9.8.
In fact, Nate, this isn't to scale. I don't know which one of these is bigger.
That.
I don't know yet. But yes, can you sort of understand why it's important here? You're not really sure if you could explain it, but you get that it's important here. Well, you don't have to, as long as you know that it's negative, right? So this is going to be minus 9.8 times 10 to the minus 4. Okay. Does anyone know what the phrase order of magnitude refers to? It's fancy scientific terms for the same ballpark. Do you know what the same ballpark means?
No.
It means that the numbers are sort of, kind of in the same general area on the numbers line, right? In other words, the order of magnitude, the exponent is pretty close or equal to each other. This is 3.2 times 10 to the minus 4. This is 9.8 times 10 to the minus 4, right?
Yeah.
If this was 3.2 times 10 to the plus 4, and this was minus 9.8 times 10 to the minus 4, which number is dramatically bigger than the other one? Well, the first one, right? And in fact, this one is so small compared to this one that this one doesn't really exist, right? These two numbers in this situation should be of the same order of magnitude. They might be off by 1 decimal place or 1 exponent, not likely 2, because that would be like comparing 100 to 1, right? So in other words, this minus 4 should be the same as that minus 4. If this is minus 4, then this one should be either minus 3 or minus 4 or minus 5. That's what I'm trying to say. Give or take 1, exactly. They got to be in the same ballpark. Otherwise, one is, giant and the other is small, and one that's so small is negative. Okay, I'm actually almost done. It says to determine the net force. Well, the net force is the electric force plus the weight force. In a standard Millikan type problem, the net force is 0 and those things are balanced. But at this point, they're not balanced. So it's 3.2 times 10 to the minus 4 plus minus 9.8 times 10 to the minus 4.
So you said they have to be in order to do this step, right?
Well, they have to be reasonably close, otherwise one overpowers the other and it doesn't really mean anything.
So to do that, like for example, with 4 and 6, you have to move the decimal 1 and 1, right?
Your calculator will do it for you. Yeah.
So it equals negative 6.
So I get minus 6.6 times 10 to the minus 4. Good. Give yourself a pat on the back if you got that. Now, look back. Does it look hard? Yeah, it looks hard. There's crazy numbers, there's exponents and decimals and all sorts of stuff going on. But really, all it is 1 mark for multiplying there, and 1 mark for multiplying there, and 1 mark for adding. That's all it really is. Now, if you can follow those 3 steps, I'd like you to think back to when we did problems like this. Just about maybe 2.5 months ago. Remember how much, oh my God, this is so hard, I'll never get this. We've come a long ways, my friends. Right? If you look back, I think you'll find, oh, that wasn't that hard.
Oh, you started like this. So,
I think you'll actually find that if you stop and think about it.
okay.
Would you like to try this one?
Not really.
I'll give you a bit of a hint. Come on, Jake. You'll notice here that I've given you the mass, I've given you the charge, and I've given you the field strength, and it says determine the net acceleration of the object. How do you get the net acceleration?
Find F net.
Yeah. What's the next step? Do exactly the same thing except now F net is equal to MA, right? And solve for A. Why don't you take a minute or two and start that at least?
Is E electric field?
E is electric field strength. The first 3 steps are identical to the sample that I did just before. If you want to wait and see it, that's fine. I'm going to do the answers up here. If you want to watch, watch. If you don't want to watch, put your head down and don't watch.
Yeah, that's fine. So it would be 3.3 if you read.
We have opposite forces, so I'm going to show them like that. We don't know which one's bigger. Charge, 9.2 times 10 to the minus 15. The electric field strength is 3.2 times 10 to the 9.
Which view are we looking for, Mr. Bennett?
Delta V, how about VF, I guess, really? I'll get there.
E equals CI plus B.
Yeah, I'll get there. I get 2.94 times 10 to the minus 5 to begin with. That is only the electric force, right?
Yep.
All good there? Brendan, am I good? Yeah? Okay. Weight force is mass times gravity. The mass is this number here. Okay? Are they in the right ballpark? Are they the same order of magnitude? They are. That's good. That's a good news thing. So the net force is the sum of those two. Does it matter what order I put them in?
No.
No. 2 plus 3 is the same as 3 plus 2. Although most people like to have the positive one out front and the negative one out back just because they don't like having that negative out front, just because. People are weird. Some of us weirder than others.
Oh.
I get a net force of minus 1.47 times 10 to the minus 5.
Oh, yeah.
Okay, so that's exactly as far as we did the first sample one, right? So what's the next step to find the net acceleration? The next step, now you'll notice over here, I wrote down, Nate, I wrote down the mass, I wrote down the Q, I wrote down the E, and then I wrote down F net equals question mark, and then I went A, and then I went B, and then I went D. These are the order that they asked me, so this is likely the order that I'm going to have to solve for them, right? Follow those steps. How do I get from F net to A? Yeah. F net is equal to MA, and I would rather see it this way, you guys. I'd rather see the substitution first.
I don't remember how the formula was started. Page 131.
The mass is 4.5 times 10 to the minus 6, and we're solving for A. And A is equal to, now be careful here, it's this divided by that.
Second.
Yeah, because you're dividing by this to get rid of this one here, right?
Yeah, like that.
And you're going to get some weird number, but it's really
Times 10.
minus 3.26.
Or 7.
Or 7 maybe, yeah. Depending on where your rounding is, right? Is that a sensical answer? Does it make sense?
What is it times 10?
There is no times 10.
What is that times 10? Negative 0. Just
So the 0 means it doesn't exist.
Oh, crap.
Now stop and think. If there was no electric force, what would be the weight force? What would be the acceleration down? Minus 9.8.
Wow.
This is saying that the electric force is making the acceleration down minus 3.26. Doesn't that make sense? Like, is this going to be bigger than 9.8? Can't be. It could be a really tiny number, but what this is saying is that it's falling at about a third, 3 instead of 9, about 1/3 of what it normally would. Does that make sense?
Do how fast it travels multiplied by that.
Okay, so now, here's the review part from way back when. You don't have to ask me, Mr. Ben, are we going to review for the exam? I'm doing it today. How do we get from acceleration to velocity? A equals delta V over delta T. The acceleration is minus 3.26. The time was 1.5. You multiply, right? You're going to multiply both sides by 1.5 to get that number there. And I get minus 4.89.
I'll do the 4.9.
Whatever. I don't care about the numbers. I care about showing the steps in the work.
So you don't care?
The process. No, I care as long as it's close.
Unless you round exactly the same, you never mix.
Yeah. I tend to never round on my calculator. Like if I've got this number in my calculator, it's probably 3.26666666, and all I did over here was multiply by 1.5. I don't round that off and retype that in. Now, if the change in velocity is minus 4.89 and the initial velocity was 0, well then that means that the final velocity is minus 4.89. So there's an answer and there's an answer. The last part says, how far will it have fallen? I need a formula with D in it.
E equals B over T.
V bar equals
V bar equals D over T.
Oh, McLaren.
Do I have V bar? No! You need this intermediate one.
Why?
2, 3,
There's no D in
4,
that.
5, 6.
You can't do V bar is D over T until you've got V bar. Does VF or delta V equal to V bar? No!
Only everyone.
You are. I like that.
Does this have to be negative here? At this point, it really doesn't matter. We're just figuring out it's all down. If you want it to be negative, you go right ahead.
It can be negative.
It can be, or I will accept. I mean, technically it's wrong, but I'm not really too concerned about it.
Then it's just distance.
What's
Yeah.
the answer on this?
2.4.
Minus 2.4 or 44 meters per second, and then that one goes over here
Oh, right.
because it's still down, right? Yeah.
The people's brains work when they fill up this much space on a piece of paper.
Well, Lucas.
The same way a quarterback can memorize pages and pages of a playbook. It's just what's important to you, Lucas.
I'm not a quarterback, though.
Well,
Well,
I'm just giving you it.
you still need to know most of the playbook as the center.
it's not laughing, so I'm kind of confused.
Surprising what you can learn when you want to.
Don't want to listen.
Well, you maybe, right?
I'm just saying that.
Holy Mr. That was a long question.
That's a long question. That is likely the hardest
That's a 7-mark question.
thing you've seen in here, right?
It's like a question.
They're all 7-mark
Oh, by the way, this would be multiple choice on the exam. Just kidding.
You're so funny.
Just kidding.
This would be a 7-mark question.
1, 2, 3, 4,
Awesome.
5, 6. Yeah, 7 marks.
You said you give us a half mark for that.
Yeah.
I never said no such thing.
Organization, right there.
I might.
Okay.
If you didn't annoy me in class, I might. Would you not agree that this is a good review of pretty much everything we've learned in physics?
Yeah.
No, not. Because we still have the...
Yeah, right.
No, because we still have the codes and the sin and stuff.
Yeah.
And vectors.
Okay.
Yeah.
I don't want to.
How about, you guys have a, okay, flip your page over, so you got that big blank spot right there, okay? Flip your page over so you got that big blank spot. Find a partner or work in a group of 3 if you need to. All I want, listen, I don't want the solution, I want the steps. I want you to write down with your partner, what are the steps that you're going to use? In other words, yes, so you'd write something, I'll get you started. No, this is just, we're going to try something different, that's all. Okay? Let's read the question. Millikan observed a droplet of unknown charge accelerating at minus 2.3. Nate, listen. He determined the mass of the droplet to be 5.3 times 10 to the minus 6. The electric field strength at the time was 3.6. What charge was on the droplet? What charge? We are solving for Q. Okay. Here's how I want you to do it. I want you to go back to question number 2.
I know this guy.
I gave you the acceleration, in other words, right here, right?
Can I just do this question?
No, I want the steps. Think about the steps. You're starting here and you're working backwards. So on the back page, I want you to write down with your partner, what are the steps? I'm going to give you about 90 seconds.
90.
That's all you're going to need. You're just coming up with the steps. I don't want the math, I want the steps.
No, Kia knows.
Oh, yeah.
Kia knows.
At least 30 after, like,
Off. Go away. Off.
Off.
Off. I turned it off.
Think about
Yes, no. You said it right here.
Oh,
Right there. It's going to the office.
Go
Get
home.
over there.
Go home.
It's fine.
Not here.
It won't buzz. It won't ring. And no one will steal it.
Josh, you're gonna buy them.
Go.
There's an empty
I'll
chair.
lock it up if you want.
Alright. Josh, you're gonna find her.
Go away.
I think we have to find.
Get. Go on. You are not. Get back there and learn to do it.
You will find out then.
No, go back there.
Take him downtown. Take your task man.
Mr. Bennett, you're still recording.
And you have the right to have that in class, is that what you're telling me? No, you don't. Not if I say no, you don't actually have that right.
You don't have that right.
You don't.
You don't.
Human rights to have your phone. You wouldn't
You
say
don't have
that,
that.
Jessica, you know it's a phone rate.
This is here.
Yeah, that's great.
Yeah, keep it up there.
You shall know.
Yep.
How do we do math?
You have the right to sit
Okay,
here.
Rain Man, let's
You have the
go.
right to sit back there. You don't have the right side.
How do we do this?
Because you're on a level. So you have to just level up.
The only right you have is to an education. That's your right. After that, it's authority rules here.
You're expressing nothing.
Everyone has the right to their own opinion.
His opinion is the GTFO, please.
Tell you what, why don't you get yourself a lawyer and take me to court? We'll see who's right or wrong. In the meantime, get back there and let's go.
Yeah, you don't even know. You don't even know.
My fight is to stay here and
Wait, that's all the office.
Hold
Yeah, here,
on.
let's go. Here, call the office. You go call Mr. Cassidy, I'll give you his extension number, and you tell him, Mr. Bennett took away the... Those of you that pulled your phone out, put it away, you guys. If you really want to succeed, you have to put the phones away. Alright, so, I was given the acceleration. Okay, listen. I was given the acceleration. From that, what can I solve for? F net. So now that I have acceleration, I can get to F net. And now that I have that, what do I'm trying to find out the charge. So I'm going to have to, do you sort of get a feeling I'm going to have to figure out FW sort of on the side, right? And then I'm going to use that and I'm going to find FE, and that's going to give me the charge. All I did was I took this example and I worked backwards. Do you think you can do it now? Give it a whirl. Those are the steps. Give it a whirl. Those are the steps. Do those steps. No, I think I'm just going to write it. Let's just go.
I kind of know what I'm doing, but I'm not. I just screwed it up. Going wrong, then I screwed it up. I really don't
Mr. Bennett, it's 1.6 times 10 to the negative 19, right? This one.
Yeah. So I'm going to find the net force first.
Times 10 to the negative 11, no, I don't think you're negative 11. Wait.
That's my net force. I have to, on the side, figure out the weight force.
I have the first one wrong, well, that's a good sign. I'm saying I got it right. No.
So you're close, you just got.
Might be out of there. So I'll be a little bit harder.
Yeah.
Is it important that the weight force be negative?
Yeah.
Yes. You guys should be watching. If you don't get this, tuning out and not watching is not going to help. Sit and watch.
Oh,
Oh, yeah.
Tomorrow?
And you bring the 5, put 2 over.
That goes to the other side, and you get,
Wait, why? Oh, yeah, okay, okay. Wait, whoa. I got like 6.42.
this one's negative. One's positive and one's negative. And if you made that mistake, Nate, that would probably be like a half mark deduction if you've shown your work. So that's okay, right?
But like, you won't care about the other answers because the other answers will go with that answer?
Yeah, I'll follow it through as long as you show your work.
It's not like it's show.
I know.
Good shit. Good shit.
Did you get around 1.1 times 10 to the 10 coulombs?
I got 1.1. I got 1.12.
That's pretty close to me. Take that number, divide by 1.6 times 10 to the minus 19, and you get about 6.9 times 10 to the 7 elementary charges.
I enjoyed it. God, good shit.